Okay, so we're going to have a look at exercise 2a, question 9. Okay, so we've been told the operation star is defined by AB equals AB plus A. Okay, where A and B are real numbers. Okay, so A and B both belong to the real numbers. And we've been asked to show that this does not form a group. Okay, so we've been asked to show that this binary operation does not form a group under the real numbers. Okay, so to check something as a group, we need to check the four properties. First of all, we'll check closure. Okay, so let's see if we combine two elements A and B, we get A times by B plus A. And now A times by B plus A must also belong to the real numbers for any A and B belong to real numbers. Okay, so what I've essentially said here is that I've said any number times another number plus that original number, if they're all real numbers, this operation, this binary operation, will give you another real number. Okay, so this binary operation respects closure. Let's check the second one. Okay, so let's check associativity. Okay, so now we have to show that it does not matter in which order we combine elements. Okay, so we can, if something is to obey associativity, we could combine A and B and then combine another element C, and that should be exactly the same as combining A and B and C kind of first and then A after. Okay, so let's check. Okay, so A combined with B is AB plus A, and now we're going to combine that with C. Okay, so this is going to be AB plus A times by C plus C. Expanding out, we're going to get ABC plus AC plus C. Okay, let's check now. Let's combine B and C first. So when we combine B and C, we're going to get BC plus B. Okay, and now when we combine that with A, we're going to get A times by that plus A. Okay, now expanding the brackets, I get ABC plus AB plus A. These two things do clearly not equal to each other, so associativity does not hold. Okay, we can also show another contradiction, well, another property that doesn't hold. So we can check now the third property, which is the identity element. Okay, so we must have an identity element E such that A combined with E exactly the same as combining E with A, and that will just give you A. Okay, so there must exist an element E for whenever you combine that element E with another element, you get the other element that you just combine it with. Okay, so you can think of like E being, so for example, the real numbers under multiplication, that group would have 1 as an identity element. Okay, because 1 times by anything, you just get the thing you started with. You know, you just get the original number. Okay, so enough of me waffling. Let's have a look at A combined with E. A combined with E is simply AE plus A. Okay, and that needs to equal A, right? A combined with E needs to equal A. Okay, and this implies that E is 0. Fair enough, E is 0. Fine. Because like a number times by 0 plus the original number, you're going to get the original number. Okay, fair enough. Let's check if it works the other way around now. So let's check E combined with A. Okay, so E combined with A is going to be EA plus E. Okay, and if E is 0, like we originally showed, this is going to turn out to be 0, because 0 times by anything plus 0 is 0. Okay, so we can say for any A not equaling to 0, obviously, if A was 0 here, this statement would work. But for any A apart from 0, E combined with A does not equal A. Okay, so the identity element is not obeyed. Okay, so the identity element does not exist. Sorry, there is no identity element. So this is not a group under this binary operation. Okay, thanks very much.